Okay, so here we're still in chapter 3.1, section 3.1, excuse me. Okay, if you can't see the notes, just let me know. Okay. All right. So here, this is just, remember what we did, some of the stuff we did last time. If we have a quadratic function like this, remember the domain is everything, all real numbers, okay? Right? Remember the domain, it's all real numbers, okay? And not only that, the vertex, right, is given by this. Remember, the vertex is where the graph changes direction, right? You might have something like y equals x squared, where, let me see actually if I draw it by a little pen here. The graph of y equals x squared, that's going to do something like this. Oh boy, well, that's actually really good for how I usually draw. So this is actually the case when a is positive, which I have down on the bottom of the slide. Okay. In this case, again, the vertex is at the very bottom where the graph changes direction. That's what the vertex is. We also have the axis of symmetry. Remember, that's the vertical line through the vertex. The way to think of that is that if you were to fold the graph like you fold a piece of paper, or if you want, I guess you could think of folding the Cartesian plane about that line, the axis of symmetry, both halves of the graph would line up. They would overlap each other perfectly. There we go. Okay. When a is negative, right? Remember, a cannot be 0, so a can only be positive or negative. In this case, the graph's going to point down like this. Now, in this case, right, the vertex is the top, the peak, I think they call it that. The top of a hill, the peak. Okay. That's what the vertex would be in this case. Good. Now, the other form of the quadratic function is this way, the standard form. I mean, I did mention this. To go from this form to this form, right? What we can do is you use a method called completing the square. I'm not going to go into that, though, for time consideration. Okay? To go the other way, you just FOIL. To go from the standard form to this form. What's nice about this form is you can get the vertex easily. It's just the point HK. That's what the vertex is. Not only that, the axis of symmetry is x equals h. That also tells you how to get h in terms of b and a. H has to be negative b over 2 times a. And of course, really, this is for any function. The y-intercept is always f of 0. And the solutions to this equation are called the X-intercepts. And down here, basically, this is what I said. If a is positive, the graph's going to point upward. And it turns out the range will actually be an interval from the y-coordinate of the vertex to infinity. Whereas if a is negative, the graph instead is going to point downward. And in that case, so it's going to point downward like this. And the range in this case will go from minus infinity to the y-coordinate of the vertex. That's what the range will be. Okay. We'll do some examples today, actually. Okay. So here's our first example. Let's say we had this one. I don't think we did this last time, if I remember correctly. But here we have, looking at this, right? We have a would be -1, right? A is the coefficient of x squared. If it's not written, that is, if it's just x squared, then a is understood to be 1. So here we get -1. B we get is 6. And C is just minus 3. Okay, so to get the vertex, we have to calculate this, right? You know, the vertex, remember, has these coordinates. So really, you have to get the first coordinate. The y coordinate, you just plug into the function. So we get negative b over 2 times a. So in this case, we get negative 6 over 2 times negative 1. Well, let me say it this way. Negative 6 over 2 times negative 1. Double negative makes it positive. 6 over 2, which is 3. Okay, for the y coordinate, we evaluate the function at this point, at this number, right? That's what the y coordinate is over here, as you can see over here. So we get f of this, which is f of 3. Plug it into the function. We get negative 3 squared plus 6 times 3 minus 3, which is negative 9 plus 18 minus 3. So we get that, and that's 6. So the vertex is the point 3, 6. The axis of symmetry, that's x equals 3. The y-intercept, again, that's just f of 0. For a quadratic function, it's actually pretty easy. It's just a constant term. Mostly because, excuse me, down here, mostly because the terms with x are going to vanish. And notice that a is negative, right? So the range of this function is going to go from minus infinity up to including the y coordinate of the vertex. I mean, I know we can always see this from the graph if we were to sketch the graph. But what's nice about this is you can actually get it without graphing. Now, to get a good graph, though, we really need the x-intercepts as well. So that's what we do here. So how can we get that? Well, we have our A, B, and C. You could always try factoring if you wanted to, but because we have, I mean, what I just did was I dived right in to the quadratic formula. We have B is right? That's 6, so negative B is negative 6. B squared is 6 squared. Minus 4AC, AC, as you can see, over 2A, 2 negative 1. So we get negative 6 plus or minus the square root of 36 minus 12 over negative 2. Okay. So we get negative 6 plus or minus the square root of 36 minus 12 over negative 2, right? Which, of course, is this. And so, again, we have 2 solutions here, right? 2 solutions. Namely, what we have here is negative 6 plus the square root of 24 over negative 2, negative 6 minus the square root of 24 over negative 2. And of course, you could do this in your calculator. I mean, this 24 is not a perfect square, so its square root is not, you know, a great decimal. That's why I'm using decimals here. I mean, I wasn't going to say this, but I guess I'll say it now. If you were to calculate the discriminant, which is b squared minus 4ac, if you calculate that alone, and if you get something that's not a perfect square, personally, then I would just dive right into the quadratic formula. So if instead of 24, we got, say, I don't know, 9 or 16 or 25, then maybe you could try factoring. But you could just use the quadratic formula. So, but once we get all our data, we can make a graph. Now, I know I made the graph using GeoGebra. Let me make the graph. I can, oh, yeah, that's right. Sorry. Got lost in my words for a second. I did sketch it using GeoGebra. Okay, but you want to make sure you draw a graph that has all these conditions, it meets it, and it looks something like this. I mean, if on an exam or something, if I ask you to sketch it by hand, it doesn't have to look exactly like this. As long as it's pointing down and all these features the graph has, that's really all I'm looking for. Okay. All right. But again, we can really get the range from the graph also, by what we did last time, right? Remember, you draw those lines. Yeah, let me draw it actually, just to be on the safe side, right? You want to do is take the graph, you draw a line to the y-axis. I mean, I started from here because if you go above the vertex, the graph's not there, right? You can see that from the graph. And then you keep on drawing horizontal lines to the graph. But even just looking at this, you should be able to see that, oh yeah, if we were to draw horizontal lines, this is horizontal, use your imagination if necessary, right? You would see that we would be going down, down forever. Maybe I should draw arrows on these just to be on the safe side. Okay. All right. Yeah, it's just something I wanted to point out. All right. Any questions on this? I didn't draw the axis of symmetry. Yeah?
When you're finding the range, how do you read it and how do you determine what it is?
What do you mean?
So the range below, it's parentheses, negative infinity, comma 6, and then bracket.
Yeah.
How would you come up with that, and how do you read that on the graph?
Oh, on the graph, what would happen is, I mean, it can be tricky from a graph because you may not have the complete graph in front of you. What you can do though is you want to see what part of the y-axis, the vertical axis, lies on the left or the right of the graph. So in this case, what I like to do is I like to draw horizontal lines either from the graph to the axis or from the axis to the graph, right? So since this horizontal line, in the loose sense, hits the graph, that tells you 6, which is what the horizontal line goes through, right? 6 is in the range. Does that make sense?
Yeah.
And if you go above, you're not going to be to the left or right of the graph, right? The graph's not up here. If you go down, however, as you can see, right? You can see that this line touches the graph. So whatever this number is on the y-axis is in the range. You're basically looking for all the y values of the points.
So it's basically saying that once you get up to 6, you cannot get any greater than that. You're going to go all the way down to negative infinity.
Exactly.
So when you're placing the negative infinity and the 6 in the interval, how do you know if the 6 goes on the left or the right?
Oh, minus infinity is always on the left. That's always the smaller one.
Right. So you do it like that. So it would be positive infinity will be on the right.
Exactly. And you never put a square bracket around minus infinity, or if the graph was pointing upward, plus infinity.
So if if this graph was flipped upside down, flip it over the vertex, and it was pointing upwards because A is that would be less than.
Right? If A was positive, right, here it's negative,
right.
But if it was positive, that's what would happen. Then you would have 6, comma, infinity. And you would have a square bracket around 6.
Because because it has that inequality sign.
Well, because 6 is in the range, that's why. And because with infinity, you can never include that because that's not a number. That's just notation for it keeps on going.
Right. Okay. All right, thank you. Yeah, that helps a lot.
All right, good. I should say this also, this procedure I'm using with the A, it'll work for quadratic functions, but not every function may have a range like this. I mean, we did see that last time anyway with those line segments, so. But I know I didn't draw arrows down. Well, I drew them now. On the graph, I probably should have, but if you forget to draw the arrows, I'm not going to take points off for that. Okay, I hope that made sense to everyone. So let me just, okay. I did answer your question, right? Whoever,
yes.
Alyssa.
Yes,
okay,
thank
just
you.
wanted to be sure. No, you're welcome. It was a good question.